Others, roll number 77. Others, can you please respond? Others, can you hear me? So currently, good morning students. Currently in my student list, there is only 33 students. So I just want to reprime you that only attendance for those 33 can be marked. If you are not here, you are attending this class, maybe getting this link from your friends or somehow, it's fine. I have no problem on that. But thing is that until or unless you are in this batch, in EduServe list, your attendance cannot be marked. So please be aware of this fact. Okay. I think it is already 9:02. We can start where we left in our last discussion. Please keep in mind, I'll share my screen also to talk about what are the contents we have covered and what we are going to discuss today. Is my screen visible to you? Is this screen visible to you? Can anybody respond?
Yes, so the screen is visible.
Visible, na? And this screen is visible. Okay. So you see, I'll just update and I'll put the number in those files, whatever we are sharing constantly in your class. So basically, we have already discussed about the drug discovery components, how it is going to happen. One PPT and one other PDF is there. Last class and day before earlier day, we had discussed about clinical trials. We started about discussion on bioavailability and absorption of drug that we started. So I mean to say dissolution, absorption and bioavailability, those components we started our discussion. We'll continue with this. So I will have this, this will be our discussion, drug absorption, and we'll also talk about some bioequivalence. Please be oriented that at this moment, we are actually in our textbook, what we have shared, this Remington. I have already shared in your group also. You can download those textbook. We'll be discussing some extent on chapter 5. Not everything. Everything is too big for you because this is only one course for you. Not the whole entire syllabus can be really important or useful also. So I'll be discussing some important aspects. I will try to highlight so that you can also, when you are checking this text, you can always have the idea what is really relevant for our discussion. Anyway, I will continue where we started our last discussion. Basically, we started talking about dissolutions, right? So how the things are going to be dissolved. Particularly when we are talking about dissolution means we are definitely talking about tablets or capsules or essentially solid dosage form. Okay. So dissolution part. Dissolution is very important step because I will say this is the first step rather when I'm going to take some solid dosage form, right? It is very important part. And what are the micro steps, intermediate steps involved? I'm having a tablet. So water is there outside because we are taking it maybe in our gastrointestinal tract, water is there. And definitely it is going to disintegrate into larger particle. I stopped it here in our last class. disintegration is important, and subsequently those particles which are being created, these are broken down particles, they can even be broken into some smaller fragments and until or unless they're getting dissolved, but they should not again aggregates. Okay, so we need to have this aggregation. These things is important, and finally they will be dissolved. Now when we are talking about dissolve, very important things you must understand that dissolve is a process where there is one control limiting things. What is the limiting things? For example, I am having 1 liter of water. Just for example, I am talking here. And I'm giving you some sugar. A pinch of sugar you are adding, just few granules, and you are stirring it using a stirring rod. What will happen? It will be dissolved, right? Completely it will be dissolved. I am taking now 5 gram of sugar, trying to dissolve, it will dissolve. If I take 500 gram of sugar, do you think it will be dissolved in 1 liter? Or maybe 1 kilogram of sugar I am trying to dissolve in 1 liter? No, it will not be dissolved. There is always one limit, and that is called solubility. Of course, you may heat it up, that is different. In ambient temperature, if I am going to do, this solution will have a maximum capacity to have the intramolecular space where the molecule will go and stay. That is known as solubility, right? Solubility is very important. Each compound has their own solubility values, limit. So we cannot dissolve anything and everything in any compartment. That is a requirement there. Now, when I am having this kind of system, if I am trying to dissolve, so whatever solubility they will go, other things will be particles, right? They are not going to be absorbed. They will be simply staying there. So solubility is one of the very important aspects. So for example, this is, let me talk about. So for example, this is esophagus and this is stomach, for example. I am taking some 500 milligram of aspirin, acetyl salicylic acid, for example. Okay, if I say about your stomach is containing your gastric juice, fluid, all those things are there. And assume the volume is around 2 liters. Now question is that when I am taking the drug, of course it will go and break and disintegrate, all those things will happen. Finally, how much will be dissolved in the fluid definitely controlled by its solubility. If the solubility of the drug at this condition, at this pH, at this volume is, for example, only 100 milligram. Just for example, I am telling, it is not the correct values I am speaking. That means whatever you do, you cannot dissolve more than 100 milligram in the fluid. So remaining 400 will be only on some small particle suspension, it will be there. Now, question is that in our system, there is, for example, we are going through like this way, but there is always a continuous someone who is receiving end. What is the receiving end? Let me talk. For example, in this situation, you try to understand that, okay, this is 1 liter, that is sure, fine. And I'm trying to dissolve some 1 kilogram of sugar, and I told no, 1 kilogram cannot be dissolved. But if this is a membrane, if this is a semi-permeable membrane and allow the sugar to pass, and there is one fluid is going through continuously, just boundary of this gastrointestinal. Why I am talking this? Because you know our gastrointestinal tract, maybe including stomach, small intestine, they are all perfused with blood vessels, right? Outside there is always a blood vessel. Now whatever is dissolved, now if they can cross this membrane, what will happen? The dissolved drug concentration will automatically fall, yes or no? For example, its capacity is only to dissolve 10 gram. For example, it can dissolve in 1 liter, maximum capacity. So 10 gram drug is dissolved in your stomach. But your stomach, intestine, all those things are perfused with a running blood, right? It is passing through a blood vessel. And if these molecules, whatever amount is dissolved, and here there is no molecule is there, so what will happen? There is a called diffusion, right? You already know, from high concentration to low concentration drug can move. So if the molecules are moving, I'll talk about their numerical things later on. So if it is moving out, what will happen? Out of the 10 gram which is already in solution, some gram will go there. It will be dissolved, it will coming to blood, and every time new fresh blood is coming. So don't think that it will be saturated. Fresh blood is passing through your systemic circulation. So continuously some amount will be dissolved. I mean to say, passing through the membrane. And as the concentration comes down, the bigger particle who were waiting in this group, they will now dissolve. Are you getting this point? So this is a continuous process. I'm having a capsule or tablet, it is getting disintegrated, then they are coming in dissolved form. There is a gatekeeper. The gatekeeper is solubility. It will decide. So if it is dissolved, and from there it is going to systematic circulation. So continuously from the dissolved state, some molecule is going there, that is diffusion controlled. Here the dissolution is actually solubility control. So there is two controlling mechanism. If this is running very fast, then no problem, dissolution will continuously go. And as the broken down, all those processes are mechanical process. So it is actually depending on gastric emptying rate, how the things is happening, how it is going down, all those process, physiological process is also very important. So when I'm talking about dissolution and absorption of any pharmaceutical dosage form, very important things are, what about your dose? Is it really breaking down? These questions will come into, you should ask these questions when I'm talking about any drug which is going to our systemic circulation. Few questions will come. The questions related to your drug and formulation, I will have some questions. And second question will come, physiological state. Physiological state means the patient, the individual. I'll ask those queries. And this is about your medicine. What questions will come? As I told you, what is the solubility? Okay, I'll also ask many other questions, like what is the pKa? I'll discuss them. What is the particle size? What is their lipophilicity of the compound? This is about the compound. For example, acetyl salicylic acid. I will also talk about the formulation. Are you giving in suspension? Because suspension will have already very small particle size, so it is already some work is done. Or we are giving in a tablet. Is the tablet coated? These questions are all relevant. Coated means, normally you'll see many tablets are there. Tablets are not colorful, but when you're purchasing some tablet, you will say some yellow color, pink color, those colors are coming. Why they are coming? Because most of the time they will coat the tablet with some sugar coating. Okay, and always some excipients will be there. Inorganic salt, magnesium is also used. So why this coating is done? Just to keep it intact, so that it does not break down, because from industry it is coming to the pharmacy shop. There is so many days are there, transportation is there. So if the tablet is not strong enough, it will break down. So if I make a coat, means we are just putting a layer so that it will be more stable. But that is having a problem for us, because when you are consuming, the coat has to dissolve fast, right? Then only the main tablet components will disintegrate. So coating is a problem for individual. Coating is a requirement for the company who is producing, because it will give you some time to stay. So very hard tablet is not good, and very friable tablet is also not good. If it is very breakable or friable, that is good for us, not good for company. So because their product will be all broken, you definitely will not purchase those broken tablets, right? So it all depends on what kind of formulation, what kind of design and dosage form we are using, how much coating is there, what are the ingredients. if you remember in our last class, we talked about filler, binding agents, all those things we talked about. What are these? These are the requirement for making a tablet. Otherwise, it is normally pressurized, right? So we are having a punch and we are putting this powder mixture and another punch is there to press out, compressed. So all tablet formulation we are mostly using are compressed tablets. Particle size, if there is very small particle size, then the compression will not really be very good. You cannot make a compact tablet here. So normally we make some granules, not really particles, not very fine particles. We'll make granules. So granule compaction is more easy and they dissolve also very easily. So many times when they're preparing tablets, we'll discuss later on when we are talking about tablets. So they prepare some granule and those granules are compressed. So what will happen? There will be some space, some intragranular space will still be there, some air pockets. These air pockets are actually somehow good also, because when the water is coming, they can also go through the pores, okay, capillary action, and they can break down. Disintegration is easy. So it all depends what kind of formulation you are using. Okay, so these are about tablet perspective. Solubility I already talked. I will definitely talk about pKa. I will partition coefficient. All those things are also important. I will talk. And physiological state, the individual, because you know I am having a tablet and it is slowly dissolving. But for example, the gastric emptying time is, for example, 30 minutes or 35 minutes. That means it is only getting 35 minutes to break down and to dissolve and to be absorbed. If your formulation is taking more time, then what will happen? It will go away. So definitely time is very, very important factor when we are considering the dissolution process. Now, if I am talking about rate of dissolution or how much it will be dissolved, finally I am taking some 100 gram or maybe 500 milligram of tablet, and how much of these tablets can actually be dissolved, it depends on three things: the solubility, it depends on time, it also depends on volume, how much liquid is there in your stomach. So essentially, maximum amount of drug which can be possibly absorbed, maximum theoretically, that is solubility multiplied time multiplied volume of your gastric juice, or I will say when I'm talking about stomach, so volume of the stomach, how much is mostly filled with your fluid. So these things gives you maximum possible amount and how much time it is staying. So if I'm increasing the time, it can be absorbed more. If I increase the solubility somehow, I will use some other salt, it can be taken more. Volume, definitely we cannot really control. Our organs volume is, the gastric volume is not in your control. So you cannot do that. You can control those two aspects. Some drugs are there which can actually reduce the gastric emptying rate. So now 35 minutes, after every 35 minutes they are passing it out. You can have some medicine which will actually increase, maybe 45 minutes or 1 hour time is increased. So these are all aspects which can decide how much drug will be finally dissolved. But dissolution is only first step. Are you getting this point? So dissolution is the first step in your system, and there may be many control means, as I talked to you, physiological controls are there, formulations are there, pKa, lipophilicity, all those things also I am coming to discuss now. Okay, so for example, this is your stomach and drug is dissolved, so I'm assuming they are dissolved, and next step is actually absorption, right? Dissolution is the first step, next step is absorption. Now, how it will be absorbed? So, for example, this is a membrane, right? In stomach, they cannot really pass because in stomach, there is a mucus layer is there, which is actually inhibiting much absorption. But if it is dissolved, next you will come to small intestine. Small intestinal wall, this blood is passing through it, right? A fluid, blood is passing. So this is a membrane, okay, where the drug molecule can quickly pass. So at what rate they will pass? So if I say d concentration dt, number of molecule passing through this, just number of molecule per second, how much is passing? It depends on three things. One is the diffusivity of the molecule. That is a property of your compound property. It will depends on area. If a large area vessel is there, a very big size area, so they are getting more space, more area to transfer. Are you getting this point? It also depends on how much thick. If it is very thick layer, then passage will be very difficult. If it is very thin layer, so actually inversely proportional to thickness. This is Fick's law of diffusion, right? So this is controlling the diffusivity, the area you have no control, because your system, your body, your small intestine, what is the surface area, you cannot stretch it or reduce it, no control on that essentially. Thickness, the membrane thickness also you cannot really do much, you have no control on this. D also you have no control. D is the compound property, what compound you are using. And the last part, possibly you have a control, that is the concentration here. This side very highly solubilized concentration, and this is the blood concentration, for example localized blood concentration. So I can say the gradient. Are you understanding what I am talking? So rate of absorptions, you please use the terminology AB, absorption. If you are studying downstream processing, you will be also learning in very few days adsorption, but this is not the case. Here it is absorb. So absorption means passing through a membrane. So rate of absorption is this one. So D is the diffusivity, which depends on the molecular characteristics. You have nothing to do on that. Surface area of your small intestine, large surface area, I know, but you have no control on this. Thickness, no control. You have control on this part. How much drug is dissolved. How much is dissolved? Of course, it has a limit also. It has a cap. That is the solubility cap. It cannot be dissolved more than its solubility, but still you can have a control how much is there. Of course, less than the solubility cap. And CB is the blood concentration. Now, what is the beautiful thing here? The blood is not constant, right? Blood is moving. So what will happen? Immediately, whatever drug is transferred, new blood will come, fresh blood. Your blood volume is, for example, 5 liters, right? So you have time. So fresh blood means CB is essentially 0. Nothing is there. As it is coming, immediately carried away. As drug is coming, carried away. So what will happen here? There will be in the bloodstream locally, the drug concentration is very low. So CB essentially can be assumed to be 0 for purpose of our diffusion calculation. So essentially, this is the transfer rate of the drug, which you can have very little control. You can only decide how much soluble you will make. That is the only thing you can change. So you understand, these are all constant things. This is one thing, and this is also another thing, which is nearly 0 for some time. But if you are continuously taking the drug, then blood concentration will not be 0, right? Because it is coming into blood, it will accumulate. So essentially, you can have the concentration gradients, you can control the concentration and all those things. Now, as I promised that I will discuss about the other two components, that is pH or pKa, lipophilicity. What are they? What are those things? Okay. Now, I'm talking about a drug absorption. Now I talk about the membrane also, right? Lipid bilayer. Okay, so essentially I am having a lipid membrane here. Phospholipid bilayer, have you studied, na? In many membrane. In case of gut membrane also like this. I'm just drawing a schematic. Okay, so this is a lipid layer, lipid bilayer, 2 layers. And now, for example, this is your small intestine, and this is your blood vessel. So the drug has to cross it. Okay, drug has to cross it. If the drug is very much hydrophilic, you know, right? And very low lipophilic. Lipophilic, hydrophilic, the terminology you know. The drug is hydrophilic means which is more favoring dissolution in water. The drug which is lipophilic drugs are mostly large molecule having some long chain. They are already hydrophobic in nature. So hydrophobic compounds, or in other words lipophilic compounds, they will be more easily absorbed because this is lipid layer is there, so they can cross it more easily without any problem. But if it is hydrophilic, there is having some resistance, they will not be more easily welcomed in the lipid bilayer membrane. So this you need to understand what kind of drug you are dealing with. If it is lipophilic drug, quickly absorb if it is having a lipid layer. But if it is a hydrophilic drug, you need to decide what form of the drug is. For example, I am taking a drug which is little bit acidic in nature. So for example, I am taking some acid. I'm just giving a symbol of HA. What will happen? If it is a acidic form, there are many acidic drugs we will be using, even many kind of in our system when we are taking these non-steroidal anti-inflammatory drug, most of them are actually ionizable. Ionizable means they can break down. So for example, my drug is some acidic drug. It can form H plus and A minus. Of course, it depends on pH, you know, right? It also depends on pH of the solution. So for example, this will only happen if the pH of this case is, for example, if I say if the pH is very high, if it is high pH, then only it will break down into this form and this form. It will be broken down, it will be ionized for acidic drug. Okay, and if it is acidic pH, acidic or low pH, if it is low pH, it will not break down. Okay, in low pH it will be remaining, mostly the drug will be unionized. So try to understand, if my drug is acidic, it can break down at high pH, it will not break down at low pH. Now question is that, if you know that our gastrointestinal tract, here pH is very high, okay, I mean sorry, pH is very low, it is acidic, low pH, stomach, slowly the pH increases in small intestine. It can go around 7.5, little bit alkaline actually. And then large intestine, you can have even little bit more basic pH, okay, approximately 7.9 to 8, not beyond that, it is not possible. So basically I understand, if I know, now question comes, okay, what is the problem if it is ionized? Is there any problem? Yes, there is a problem. This A ionized form cannot cross this membrane. No. Only unbroken molecules can cross this membrane. So what is your intention? Your intention is that, okay, my drug molecule should not break down. If it is breaking down, a problem. Now what can you do? Where it will break down? I told you at low pH, no issue. So that means in stomach area or early small intestinal area, if my drug is released, it will be absorbed because mostly in the HA form. But if it is not broken down and it is taking some time to break down and coming into large intestinal area, then its pH is very high comparatively, and your drug will be all broken down, and broken down drug is not absorbed. Okay, so please listen carefully on those aspects. So if I know my molecule will ionize, I'll try to make it absorb in stomach and very early part of the small intestine. I want the drug should be always ready so that it can be absorbed. If the drug is not broken down in this portion, then it has to go away and nothing will happen. So you be careful when I'm selecting what kind of drug molecule is there. Now, okay, when I talk about pKa, you know those terms? Of course, you should know this because you have studied to some extent. Now, what is Ka? Ionization constant, right? So I'll just talk about very quickly. This is background theory, not related to pharmaceutics. So for example, I'm having HA1 drug. It can ionize to H and A minus. So Ka, equilibrium constant for ionization, I will write like this. It is plus two things I'm talking, just for recapping. If you remember this, no issue on that. So what can I say? H plus A minus equal to HA and K. Okay. Now, what is pH? pH is negative logarithm of hydrogen ion concentration. Yes or no? Similarly, pKa is same thing, negative logarithm of Ka. That's all. Now, if I make a log of this, I'm taking a logarithm of these components. So what will happen? Log mathematics a little bit. I'll stop it very quickly. Log here also. Log of plus log of. If I put minus everywhere, so negative logarithm of hydrogen plus ion concentration is pH, yes or no? pH minus log of A minus log of HA. What is this? Negative logarithm of K is? Yes or no? So what is happening? I can say pKa, you see, just organizing, equal to pH plus log HA minus log A, or simply I can say pH plus log of HA by A. Done. So, okay, fine. Now, what does it means? What does it indicates to you? So, if I am having a drug, try to understand. This is very important formula I am going to take. So, drug has its own K value is there. You have no control. Ionization things of the drug is its own property. So, for example, I am having, try to understand, if I am having some pK value of the drug I know and pH is known. So, for example, pK is 6 and my pH of the solution means in your stomach or intestine, whatever pH. So, for example, pH is 7. So, you understand that log HA by A value will be negative. So, I can control, I should know that which value will be higher. It will be more ionized or less ionized. Okay. So, this value pKa and pH, if I know both of them, then I can find out, okay, in this case, log HA by A will be negative, right? -1. So I can calculate it. What will be the HA by A? 10 to the power -1. Yes or no? 10 to the power -1 means 0.1. Am I clear? It is 0.1. So what is happening? HA by A ratio is becoming 0.1. That means the ratio of your unionized A is unionized component is very big. So your drug will be, your drug will be more ionized form if I'm going to having a pH which is higher than pK. So these kinds of assessment you can make. So if I know the drug, I can tell you at what pH or where you want to have your drug molecule to be absorbed. Am I clear? pH, pK, how it can be controlled, and how is it going to influence the absorption of your drug. So this, if you have any questions on this, you can ask me. Now onward, I will go to one slide. These are all fundamental discussion we had. Any questions from your side, please? Any question? You are all there or you have left this class? Looks you are present. Sridarsani, Resma, can you hear me?
Yes, sir.
Do you understand what we are talking?
Yes, sir. Yes, sir.
Any Rima, do you understand any question?
Yes, sir.
Sanjay? Sanjay?
Yes, sir. Understood, sir.
You understand?
Yes, sir.
Okay, you are very quick on switching on the mic and switching off the mic. Good. So basically, that was the theoretical part, but I should also take help of some PPT so that you are not going out of track. And we are going to take, yes, here, drug absorption part. This actually I downloaded. This is not my own PPT, so I don't get the credit for that. But essentially, I want to, so this is a very big one. Everything is not included. I think my screen is visible and I can go on continuing the discussion. So when I'm talking about the drug, essentially you need to know I'm having some oral drug, absorption process is there, and finally it is coming into blood or plasma, and finally it will go into different distribution process. So this is very simple thing, very much not needed. So what is drug? We already talked. Definition of absorptions, I already told. Process of movement of unchanged drug from the site of administration to systemic circulation. That means blood. How is it going to happen? The effectiveness of the drug can only be assessed by its concentration in the site of action. It is difficult to measure drug concentration at every site. So we are only mostly measuring in blood or blood plasma. Those concentration will be measuring. Now here they are talking about how the things is going to move. As I told you, cell membrane structure and physiology, you can see this is actually not related to pharmaceutics definitely, but you must have studied these kinds of membrane structure in some physiology class. I'm not sure which subject you have studied. Even in microbiology also they will be talking about the membrane, transmembrane transport. I think in biochemistry you have, I'm not very sure, but I'm sure that you have studied. And large number of molecule can pass through this. These are some protein, that is porine proteins through which directly something. So these are different gates. Someone will go through the membrane with much difficulty. Hydrophobic drug will very quickly go. There will be some transporter. There are many physiological steps are there. So cell membrane separating the living cell. And why I'm talking about cell membrane? Because this is the wall between your intestine, large or small intestine or stomach, and the blood vessel. So there is a membrane. So we need to think about the membrane, how it is going to traffic. It can be selectively permeable because it depends on what kind of compound. I told about hydrophobic and hydrophilic compounds are there. I told about their phospholipid, right? Phospholipid protein, other macromolecules are there in the membrane. So we already discussed. This is the membrane structure they are talking about. There are many different kinds of membrane proteins are there. You study. I have no intention on that because they are talking about antigen, integral protein. But essentially, we are not really bothered on much of this. Now, physiological factor affecting oral absorption. You please remember, this is important aspects we are talking about. How the passage is happening, active transport. Active means someone is taking part, some transport molecules are involved. Facilitated diffusion, which is automatically being controlled by a liquid blood vessel through which blood is passing continuously. Passive diffusion is always happening, it is a natural phenomena. Ion pair formation is happening for some drug molecule. Okay, I was talking about drug molecules. Let me tell, some of the drug molecules are always ionized. So do you think that they will never be absorbed? No, they will be absorbed. But someone will come and bind with them. So they're already ionized. Na? Some opposite charge molecule will come and bind with them to make them neutral. So that is called ion pair. Try to understand. So your drug is always ionized, either positively charged or negatively charged, whatever may be. In our physiological systems, there may be some other molecule, macromolecule, which are oppositely charged. So they will come and bind. So binding will make them neutral charge, opposite charge binding. And the whole pair, this is also ion, this is also ion. They will make a coupling. Coupling means they are becoming now neutral and they will pass. So this is ion pair formation is also important in many times in our pharmaceutical dosage form. Sometime in the formulation itself, we put some ion pair. Okay, it is not, we are not depending on our system. We are putting already some ion pair which will be oppositely charged and they will bind. So together they can transfer, they can transport will happen. And what are the factors? It is depending on physiological factor, the human being, physiochemical factor of the drugs, and formulation factor. I was telling now how much coating you will give, all those process will happen. Now, mechanism of drug absorption, you need not study much details. You can skip. Just for example, you can go through quickly how it is happening. This is lipid bilayer. This is blood, this side, and this side is your drug. So drug is starting coming into your bloodstream, you see, crossing. So what will happen? In your gastrointestinal tract, drug concentration will fall down. You see, it is decreasing. And in blood, it is increasing. How it will happen? It depends on Fick's law. I already talked about D, A, some constant, and the thickness of the membrane, and concentration in gastrointestinal tract, concentration in blood. These things I already discussed, so you can just skip it. In blood, what is happening? There is always known as sink condition. Sink means in bloodstream, it is continuously flowing. So drug concentration will always be immediately finished. It is a sink. Sink means drain, right? You have seen your maybe in household basin there is a sink where everything will go and get down. So in blood also, near your peripheral blood system, so when it is the blood vessels are there, continuously fresh blood sweeping in. So always there is a demand because there is no drug in the blood, so diffusion will continue for larger period of time. Okay, these things you can simply think. In sink condition, C is very small. I told na, it is nearly zero. So blood concentration in that location may be very close to zero. So diffusion is very good, very high speed it will happen. So essentially they are putting a very simple equation. I also told you, it only depends on transfer rate, will depends on how much concentration they are in your gastrointestinal tract. So this process you need to understand. Pore transport and transfusion, it is depends on you. Ion pair transport, I was telling, it is some drugs which are always ionized, they need some partner, so they will bind and do. These things are not really, we are expecting not really that they should go through complete details, except those things which I am highlighting. You may please be focusing on that. Okay, ion pair transport is relevant because many pharmaceutical formulation will require addition of ion pair. Facilitated diffusion, active transport, these are already you have studied. I'm just skipping them, not relevant for us. Phagocytosis, pinocytosis, these are a biological process. Now, factor affecting the rate of absorption. Please go through. I told you drug solubility and dissolution rate. Both are important. In the very beginning of this class today also I discussed about maximum observable dose, MAD. What I told, there is some intrinsic rate, there is the volume of gastrointestinal tract, I told you, the time of residence, how much time the drug is getting to stay there, and solubility of the drug. So solubility, volume, and time, and this is a proportionality constant, it is a rate constant. Okay, so this is the very important aspects which you can decide what should be the dosage form you are using. You cannot take any dose. If I take, instead of 500 milligram or 600 milligram of some antibiotic I am taking, if I am taking 2 gram, do not assume that everything will be absorbed. They will simply go away because they are not getting time to absorb. Solubility is too less. So these are the driving parameter which will talk about how much will be absorbed. Now solubility and permeability. Solubility is in your control. Permeability is not in your control. Permeability depends on physiology. So if solubility is also high, permeability high means it will be very good absorbed. So what is the rate limiting step? Gastric emptying rate. So if gastric emptying rate means how much time it will stay there. If solubility is low and permeability is high, then absorption can be variable, and it will be rate limiting step will be its dissolution. It is not dissolving, that is the problem. If solubility is high for a formulation and permeability is low, that means we need to improve the permeation to cross the membrane. Some example of this kinds of drug has been given, and sometimes both can be low. Solubility, permeability, both can be low. So how can you manage, and how can be the rate limiting step, which is the more important step, we need to decide by case to case basis. Particle size is very important for dissolution. If particle size is very small, surface area is very big, you see, particle size and surface area are inverse. So I can have larger surface area, and surface area is more means dissolution will take place more. More water molecule can come and sit so that they can slowly take out the active ingredients into solution. So these are the basic theory, you can study on this. Not required. And last part, salt form of the drug. I was telling you, many drug can be weak acid or weak base, so they will be ionized, right? Weakly acidic drug, strong base salt, weakly basic drug and strong acidic salt, that can salt formation happens. So I was talking about some weak acids. So what will happen? It will be ionized, diffusion layer pH is high, bulk of the solution relatively low pH 1 to 3, diffusion of the soluble particle will happen. So if it is going to be soluble, they will be absorbed. If they are not going to be soluble, they will dissolve and drug dissolution will take place, or they may form fine precipitate of the weak acid because they are no more soluble. Depending on solubility and pH, you can have a control. As I discussed in just a few minutes back about ionization of the molecule, you can decide. Drug PK and pH. Read this, very important for any formulation. Okay. Drug lipophilicity, how much it is lipid liking. So if it is too much hydrophobic, it can be absorbed on the lipid membrane. If it is too much hydrophilic, they cannot be absorbed. So we need to have aqueous solubility also, and it should have the partitioning into lipid membrane. So both the things are important. It should dissolve also, it should cross the membrane also. So we need some balance. You can check. Drugs, these things are formulation factor, disintegration time, how long time it is going to take for breaking down, important. So important things I'm just highlighting, which you will focus. Manufacturing variable, I talked about granulation, you remember, right? Wet granulation, dry granulation, compression, these things are also really important when you are talking. Compressive force, packaging, dosage form, I told about solution, suspension, tablet. So if it is a solution form, it is very easy to absorb. If it is suspension, it is better. Tablets is okay. Capsule is coated. These things will make it more problematic. So if I'm having more coating, so you need to understand solution is always good. Suspension is better. Capsule, tablets, coated tablet is more difficult. Entry coated tablet will be more difficult. So you need to understand there is always some barrier. You go through them. I think Patient-related factor is what is the GI pH. Individual person may have different pH in their gastrointestinal tract, some variation. You may please check these slides only. Rest of the thing, I think you can fluid volume. Okay, this is fine. Up to this point, you can go. Age, all those things we can ignore. Other things you can ignore. Some few slides was there. So I just highlighted the important aspects what we talk about absorption today. Next class we will be talking about bioequivalence. Any questions, any doubt or clarification you need, you may please tell me. Any questions you have on